Hello. So this is what I look like. It's been pointed out to me that this example somehow got skipped over in the lecture video from the section on trigonometric integrals. So I'm going to do it for you right now. So it's very similar to the one you did that was like just sine cubed or cosine cubed. We have something to use as our u and something to use as our du. Like we want to say u is sine and du is cosine, but we can't yet because it's not just cosine, it's cosine to the fifth, obviously. So it's always the same trick. And this is anytime you have mixed, even and odd powers of sine and cosine, whichever way it is. Okay, so here's the trick. You're going to bust one factor of cosine off. And that's because that's the odd one. So you're always going to take whichever one is raised to the odd power and separate one factor from that. And you'll see why. So now you're left over with an even power. Okay, so now we have something to use as our du. So the ultimate goal here is to say u is sine, du is cosine. Now we still can't do that because we have this other stuff in here, right? We have this cosine to the fourth. But you know that you can always take powers of cosine and write them as in terms of sine. And there's one more step we have to take before we even do that, though. So we're going to take that cosine to the fourth and see if you believe me. Cosine to the fourth is the same as cosine squared squared. And the beauty of having an even power of cosine now is that we're always going to be able to do that. We're always going to be able to write it as cosine squared to a power. And then, you see what's coming? We're going to take this cosine squared and we're going to write it as 1 minus sine squared. So you see what I mean? How it is similar to the one you did before that just had one or the other. So let's see, too much talking. 1 minus sine, yes. So now just use the one big trig identity that we always expect you to remember forever. That cosine squared is 1 minus sine squared. Okay, and now look what we have. If we let u equal sine, we've got u to the fourth, fine. We've got 1 minus u squared, quantity squared, fine. And then we've got du. So now we can do it. So we haven't done any calculus yet, right? Everything up to here has just been using trig identities and algebra. The actual integration here couldn't be easier. It's just this stuff. Okay, so let's do it. Let's let u equal sine of x. Du is cosine of x dx. So this whole enchilada becomes integral of u to the fourth times 1 minus u squared squared du. And now it's just a straight up polynomial. We have to work with it a little bit more, but right now it couldn't be easier to integrate. So I think you could probably handle it from here, but we've come this far. So let me just walk you through the rest of it. So first, so you can't do it yet. You have to actually square this stuff out. So let's see, 1 minus u squared squared is 1 minus 2u squared plus u to the fourth. And then we have to distribute that u to the fourth out. So you see what I mean? It's just a big polynomial. It's u to the fourth minus 2u to the sixth plus u to the eighth. All right, now it's just straight up power rule. You see the integration here is the easy part. So that's u to the fifth over 5 minus what, 2/7 u to the seventh plus u to the ninth over 9. I'm not going to bother with the plus c until the very end. And then remember, don't come this far just to, drop the ball at the end. What was u in the first place? It was sine of x. So your final result, the integral is sine to the fifth of x over 5 minus 2/7 sine to the seventh of x. Come down here, plus sine to the ninth of x over 9 plus c. So not at all what you'd expect when you started this problem, right? But that's always the move. And there's a similar move for mixed powers of tangent and secant. But for sine and cosine, if one's even and one's odd, you're always going to bust one off from the odd one. Then you have nothing but even powers of sine and cosine, and you can always rewrite those in terms of each other. And then you can do a pretty simple u substitution. Okay? Thank you.